This lesson is the beginning of Chapter 6, and we're going to be reviewing exponent rules. So remember, exponent expressions are when you have a variable that's raised to a power. So something like x cubed or 3x quantity to the fifth, something where there's an exponent on a variable or on an expression. Okay, so first of all, these are all properties that you should already be familiar with, but this is just kind of a refresher. Anything to the 0 power is equal to 1. So that means that in this situation, it doesn't matter what that is. It could be anything at all, except for the number 0, because technically 0 to the 0 is undefined. So you don't really use that expression. But anything else raised to the 0 power is equal to 1. So that's a shortcut if you happen to notice that something is raised to the 0 power, then it's equal to 1. So in the second expression here, also notice that this is something raised to the 0 power, so it's also equal to 1. You don't need to bother doing anything other than just saying, oh, it's to the 0 power, so it's 1. Second property, when you have a negative exponent, it does not make the quantity negative. A negative exponent moves the expression or the quantity up or down and makes the exponent positive. So, for example, x to the negative 5, technically right now it's in the numerator. So we're going to grab that, move it down to the denominator, and change the exponent and make the exponent positive. So that will turn into 1 over x to the positive 5. 2 to the negative 3. Again, technically that's in the numerator, so we're going to grab that quantity, move it down, and make the exponent positive. So it'll become 1 over 2 to the positive 3. Now, we're not taking the reciprocal. We're moving the quantity up or down. So if, for example, this was 3x to the negative 5, the 3 would stay where it is because it doesn't have a negative exponent. So this guy would move down, and that would turn into 3 on the top with an x to the positive 5 on the bottom. The 3 would not move, just the x to the negative 5 would move, and it would go to the bottom and leaving the 3 on the top. Okay, for the next problem here, think of this again over 1. So which things have a negative exponent? Well, negative 2 is not an exponent. That's a normal number. So we're not going to do anything with that. We're going to take our a to the negative 3 that has a negative exponent, move it down and make the exponent positive. That's the only thing that has a negative exponent. So this will be negative 2b squared. That stays where it was, and then the a to the negative 3 goes to the bottom, and the exponent becomes positive. So it's negative 2b squared over a to the third. Okay, the next rule is when you have like bases and you're multiplying them together, the exponents are added. When you're multiplying like bases, you add the exponents. That means when you have x to the 5th times x squared, that's x to the 7th. Why does that make sense? Well, you have x times x times x times x times x. There's x to the 5th. And you're multiplying that by x times x. So what is that? Well, there's 7 x's being multiplied, which means you're basically just counting up the x's and getting x to the 7th. Now, what happens when you have numbers mixed in? Now, this is still all multiplication. So we're just going to multiply the outside numbers together. So those guys get multiplied together, and that's negative 21. And then we're multiplying x squared times x cubed. So we add the exponents, and it becomes x to the 5th. Negative 21x to the 5th. Okay, in the next problem, same idea. We're multiplying the front numbers here together. So since there's 2 negatives, that will become a positive 15. And then we're going to group all the combine all the like bases together. So a to the first and a squared. When we multiply, we add exponents. Remember, that's a 1. So that'll be a to the third. There is only one b term, so it'll stay b. And then we have a c to the fourth and a c to the first. Will become, again, multiply like bases, add exponents. 4 plus 1 gives us c to the fifth. Now, always on all of these problems, if we ended up with a negative exponent, we're going to go ahead and take care of that by moving the term up or moving it down. None of those had negative exponents, but we always want to keep in mind that it's not simplified if it has a negative exponent. Okay, next rule is division. When you have a division problem and the bases are the same, the exponents are subtracted. When you divide like bases, you subtract the exponents. Okay, that means that on the first problem, it would be 8 minus 3, which gives us x to the fifth. Now, why does that make sense? Again, we've got 8, 2, 3, 4, 5, 6, 7, 8 x's on the top. We're dividing by x times x times x on the bottom. What happens? Well, there goes 1, there goes 2, there goes 3. What do we have left? We have x to the fifth, and it's in the numerator because there were more x's on the top. So it becomes x to the positive 5. If there were more on the bottom, the x's would have shown up in the denominator instead. Okay, so like the first problem here. The 3 is a normal number. We're just going to leave it as 3. Now, 2 ways you can do this. I usually think of it like, well, we have 3 a's on the top and 5 on the bottom, so therefore we have 2 more on the bottom. So 3 of them would drop out. 3 a's multiplied together would cancel, and there'd be 2 left over in the denominator. And then on the second one, you've got 1 b multiplied on the top and 4 of them on the bottom, which means there'd be 3 left over in the denominator. So that would leave you with 3 in the numerator and a squared b cubed in the denominator. Now, if you prefer, you can use the subtraction rule here and say, okay, 3 stays 3. A to the 3 minus 5 is negative 2. B to the 1 minus 4 is negative 3. But remember, that's not simplified, so that will have to turn into, leave the 3 where it is. It does not have a negative exponent. It stays where it is. And these guys move down. So they move down and become positive exponent of a squared, and positive exponent there makes it b to the third. Same answer, 2 different ways of doing it. Now, be careful if you're going to do this canceling out kind of method like I was talking about here. Make sure that you only do that if they're positive exponents. So when you're counting and canceling, you want to have all the exponents positive so that you're really sure whether the quantity is in the numerator or in the denominator. Okay, next problem. Now, remember, exponents are subtracted. These are normal numbers. What's 10 over 15? Okay, it's not going to be negative 5. You're not subtracting those numbers because those are not exponents. 10 over 15, you can divide out a 5 on the top and the bottom, which gives you 2 over 3. So the number part in the front is simply 2 over 3. Okay, now x squared on the top and 1x on the bottom leaves us with 1x in the numerator, and a y on the top and a y squared on the bottom. Again, one y would cancel. You'd have a y squared in the denominator. Now again, you can subtract and say x to the second over x to the first would be x to the 2 minus 1, and you can say y, so it's over 2/3 here, and you can say y to the first and y divided by y to the third is y to the 1 minus 3, and that will give you 2/3 x to the first, y to the negative second, y to the negative second, and then that has to turn into the same thing that we had up here, because you cannot leave an exponent negative. So 2 stays in the numerator, 3 stays in the denominator, x on top, y squared on the bottom. So it'll turn into this answer if you do the subtraction. Okay, and then the last rule is when a quantity is being raised to a power. A quantity with an exponent is being raised to another exponent. So you have something in parentheses raised to a power. In that case, the exponents are multiplied. That's called a power to a power. In that case, the exponents are multiplied together. So power to a power, you multiply. So if you had like a to the 5th and you were raising it to the 10th power, that would become a to the 50th. You're not adding the exponents and you're not raising the exponents to a power. You're multiplying those numbers together. Generally, you have parentheses on these problems, so when you see those parentheses, it should help you remember to multiply those. Now, also, this encompasses the problems where you have a quantity in parentheses that's raised to a quantity where there's more than one thing inside. So on this problem here, you have a quantity AB that's being raised to an exponent. In that case, the exponent applies to both parts inside. So A gets raised to the M and B gets raised to the M. So let's say you had like A to the 2nd, B to the 5th, and you raise that to the 3rd power. The 3 applies to both parts. So that would become A to the, we're multiplying the exponents, so 2 times 3 is 6. And then B to the 5 times 3 is 15. Power to a power, you multiply the exponents. And then same idea when it's a fraction inside of the parentheses. In that case also, the exponent applies to everything inside. So both parts are raised to that power. So if you had 5 to the 1st over 2 to the 3rd, and you raise that to the 2nd power, that would become 5 to the 1 times 2 is 2, and 2 to the exponent 3 times 2 is 6, and then you could simplify that out. And that would become 25 over 64, which cannot be simplified. 64, and that would be your final answer. Okay, so a few more examples here. You always want to make sure that you do not leave any negative exponents in your answer. So this will always say write without negative exponents, and you should know that if there are negative exponents, you need to get rid of them. Okay, so power to a power, we're multiplying the exponents together. So the first one would turn out to be x to the 2 times 5 is 10. You're not raising the exponent to a power, you're multiplying the little numbers together. So x to the 10th power. And again, this kind of makes sense because you would go x times x is x squared. X times x is your x squared. You have 5 groups of those. Right, because you have x squared, x squared, x squared, x squared, x squared that's being multiplied 5 times. Well, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's being multiplied, which is x to the 10th. Okay, the second one, the exponent applies to everything inside. Okay, now, 5 is a normal number. I'm going to write this in a couple of steps here just so we can keep track of what's happening. 5 is being raised to the 2nd power. X squared is being raised to the 2nd power. Y is being raised to the 2nd, and Z cubed is being raised to the 2nd. That makes it 25. X to the power to a power, you multiply, make it x to the 4th. Y squared. And then power to a power, 3 times 2 is 6. So 25, x to the 4th, y squared, z to the 6th. And then lastly, fraction, everything inside is being raised to the power. So that 3 exponent applies to everything. Now, remember, 2 is a normal number. It's being cubed. X to the 4th is being cubed. In the denominator, 3 is being cubed, and y squared is being cubed. So, the normal numbers, 2 to the 3rd is 8. Power to a power, you multiply those exponents, so that'll become x to the 12th from the top. On the bottom, 3 to the third is 27. Again, that's a normal number that's being raised to a power. So it's 3 times 3 times 3, which is 27. It's not just 3 times 3, just like the top is not 2 times 3. It's 2 times 2 times 2. Okay, on the bottom we're multiplying exponents, so y to the second is being cubed. Multiply those exponents, you've got y to the 6th. You always want to look at these numbers out here and see if there's anything you can simplify out. So maybe you could divide a 2 out of both or 5 out of both. If there's some number you can divide out, you would do that. And then you always want to make sure you've combined all the like bases on the exponents, on the, the base, the variables, and then that there are no negative exponents. It's very important you always look for that. Okay, lastly, here's a problem that has kind of a lot going on. You have a fraction that's raised to a power, and each of those things inside has an exponent on it. So first of all, I'm going to notice that right there, that b to the first is just 1, and since it's being multiplied in the denominator, we can really just ignore it. Now, there's a few different ways you can do this problem. So here's option number 1. You can just go through and apply that -2 to everything and say, okay, a to the, where we're multiplying exponents, and -1 times -2 is 2. B to the second raised to the -2, you're multiplying 2 by -2 and getting a negative the fourth. Then c to the -3rd raised to the -2nd, multiply the exponents, and it's -2 times -3, which is positive 6. In the denominator, a to the -2nd is being raised to the -2nd, which is a to the 4th. The b to the 0, you can just ignore because it's being multiplied by 1. And then c to the first raised to the -2nd, we're multiplying the exponents, and it becomes -2. Okay, so one way to start is to go ahead and just use that exponent in all the different quantities there. Okay, and then you're not finished because you still have bases that are not combined together. So I would probably go through here, and I just think, for me personally, I think it's easiest to go ahead and move these guys around. So remember, when you move, using the negative exponents, when you move up or move down, the exponent becomes positive. So a to the second stays where it is. C to the 6th stays where it is. A to the 4th stays where it is. The b to the -4th that was on the top is going to the denominator, becoming b to the positive 4. C to the -2nd on the bottom is going to the top and becoming c to the positive 2nd. And then I'm going to combine like bases here. So when you divide like bases, you subtract the exponents, or you can think about canceling and saying there's 2 more a's on the bottom than there are on the top. So it's a squared. If you subtract it, it'd be 2 minus 4, which is -2, and that means that it would move the denominator to become a positive 2 exponent. And then our c to the 6 times c squared. Remember up here, when we multiply like bases, we add the exponents. So that'll be c to the 8th, like you're just counting up. You have 6 c's multiplied and 2 c's multiplied, so it's a total of c to the 8th. And then our b to the 4th on the bottom stays b to the 4th. And then you've combined all the like bases. There's no negative exponents, so that's your final answer. Now, there are other ways you could start this problem. So for example, maybe you decide you want to simplify inside, the quantity inside first. So just go ahead and combine that down into a single, like kind of simplified as much as possible, and then worry about the negative exponent. So if you prefer to combine the a's, the b's, and the c's first, you can do that. You may want to do that by taking inside the parentheses, a to the -1 moves down and becomes an a to the first on the bottom. And the a to the -2nd moves up and becomes an a to the squared on the top. And then our b squared stays where it is. Our c on the bottom stays where it is. And then our c to the -3rd would become a c to the positive 3rd on the bottom. So if you want to go this route, then you can continue that and say we still have raised to the -2nd. Inside, we'll have a to the 1st on the top, a b squared on the top, and a c to the 4th on the bottom. Okay, whoops, I did not mean to make that positive. C to the negative, that quantity to the -2nd there. That was my mistake. I did not mean to do anything to that exponent. Okay, so then you would go ahead and apply that exponent to everything. So it goes to all of these guys, which makes it a to the power 2 power you multiply them is negative 2. 2 times negative 2 is negative 4. And c to the negative 4th to the negative 2nd, multiply those exponents makes it negative 8. Now remember, each of those quantities has to be moved around because all of them have negative exponents. So all those negative exponents switch. C to the 8th on the top, a to the 2nd on the bottom, b to the 4th on the bottom, and notice that we have the same answer as we did in the previous way. Sometimes problems are easier to do one way versus another way. If you start a problem and it seems like it's getting kind of crazy out of control, you can always start over again and see if it's easier to maybe tackle it a different way. One last thing, I do want to remind you or tell you, if you don't remember this, that when you have a fraction raised to a negative exponent, let's say it's just negative 1, what that does is flip over the fraction. So because you're basically kind of taking care of the negative exponents by moving tops to bottoms and bottoms to tops, that would just become b over a to the positive 1. So let's say you had like x squared over y to the negative 3rd, and it was being raised to the negative 5th power. That's the same thing as y to the negative 3rd over x squared raised to the positive 5. So what did I do? I just flipped those guys over and I changed the exponent into a positive exponent. So a negative exponent on a fraction is just the reciprocal, so it flips over the fraction inside. It doesn't change anything about the exponent, it just flips it over. Okay, so this one would simplify then to be y to the negative 15th, power to power multiplying, x to the 2 times 5 is 10, and then it would become 1 over y to the 15th, x to the 10th when we moved that down to the denominator. That would be your final answer. Okay, this is the end of our refresher on exponents, and now you'll have some practice on exponents.